Hello everyone, welcome back to Finite Element Methods Laboratory. I am Rakesh VALASA. In this video lecture, I am going to explain how to solve the given TRUSS problem in ANSYS Workbench software. Here I am going to solve the given problem in Static Structural Analysis module to determine the deflections at each joint of the truss under given loading conditions. The problem description is: truss bridges can span long distances and support heavy weights without intermediate supports. They are economical to construct and are available in a wide variety of styles. Consider the following planar truss constructed of wooden timbers, which can be used in parallel to form bridges. Determine the deflections at each joint of the truss under the given loading conditions. This is the given truss member. Here first node and last node both are fixed, and in between these three nodes having 30 kilonewtons acting downwards. So total load is 30 plus 30 plus 30, that is 90 kilonewtons acting in the downside. Each member length is 1 meter. Material properties and metal properties given, that is Douglas for Young's modulus is 13.1 gigapascal. You need to convert this gigapascal into pascal. 1 gigapascal equal to 10 power 9 pascal. Poisson ratio mu equal to 0.29. This member cross section height is 6 cm, width 6 cm. So this is the square cross section. We need to construct this truss member in ANSYS Workbench. Let us see how to open ANSYS Workbench. Go to Start button. Expand this ANSYS 19.2 and choose Workbench. Just click on Workbench 19.2. Now it's open like this. Now we need to save the, before going to do anything in this ANSYS or any software, first we need to save the file. Click on Save. The file name is truss, then the extension file for this ANSYS Workbench, that is WBPJ, that means Workbench project. Then click on Save. First we need to choose the module. In the left side toolbox it's showing different types of modules. Among these I am choosing static structural module. Double click on this static structural module. Now it is open like this. First one is static structural, second one is engineering data, third geometry, fourth model, fifth setup, sixth solution, 7 results. Thus go to second one, engineering data. Double click on this engineering data. Okay, it is open like this. First we need to add the new material here. So click here to add a new material. The material name is Douglas, DOU glass fur. Now add the properties for this Douglas fur. So in the left side choose linear elastic. Double click on this isotropic elasticity. In that two properties are enabled, that is Young's modulus, second one Poisson ratio. First choose the Young's modulus, that is given that 13.1 gigapascal, that is E9. Poisson ratio is 0.29. Okay, after this close this window. For then next step is you need to create a geometry. In that geometry part, choose geometry, click mouse right button and choose new design modeler geometry. Now the new design geometry model is loading. It takes 20 seconds to 30 seconds. In the left side tray outline showing different types of planes. Among these I am choosing XY plane. choose XY plane, click mouse right button and select locate. In the given structure having each member length is maximum length is 1 meter, so that's why you can see here here minimum is 0, maximum 30 meters. First you can zoom out this length just with the help of mouse scrolling button, just you can zoom out. Okay, first we need to draw the sketch by using sketch. Choose the line tool. You can start from here, draw the triangle start point end point, then start point end point, start point end point, similar to the left side, start end, start end, start end, then start end, then also draw the vertical lines here, start end, start end. Next also draw one more vertical line here, start end. Then apply the constraints. Choose the horizontal constraint. This is the horizontal constraint. Then choose the vertical constraint. This is the vertical constraint. This is also vertical constraint. Then give the dimensions by using dimension option. Choose the horizontal. Choose the first node, second node, drag to the downside. Next these two nodes, drag downside. Then choose these two nodes, drag downside. Then these two nodes, drag downside. Next vertical, select these two nodes. Here this means h2 h3 and this vertical distance are over constraint, because these three are gives the same distance, so other, that's why you no need to give this vertical distance. Then give the dimensions h1 1 meter, h2 1 meter, h3 1 meter, h4 1 meter. You can see here this middle line is not connected with this horizontal line, so go to the modify, extend this line, select this line. Now this line is connected with this horizontal line. Okay, after this go to the concepts, lines from sketches, choose this line, then click on apply. Now click on generate. The line body is created. Then we need to create the cross section. Go to the concepts, cross section, rectangular. In the given problem, this cross section is square cross section, height equal to width equal 6 centimeters. So first go to the units, change the meter to centimeter. This width is 6 centimeters, height is 6 centimeters. Then choose line body, click on this cross section not selected, choose rectangle and generate. Okay, for seeing that cross section, go to the view, cross section solids. You can see here that cross section is added to this structure. Now the geometry part is completed. Now close this window. Then next step is we need to apply the supports and loads in the model. Double click on the model option. Now the model is loading. It also takes 30 seconds to 60 seconds. Now the model is loaded in this project. Then go to the geometry, choose the line body. Okay, choose the material. The material is Douglas fir. Okay, the next step is apply the mesh. Choose the mesh, click mouse right button, generate mesh. Mesh means divide that structure into small elements. This is the default mesh. You can also divide the entire structure into your required elements. So for that purpose, go to the mesh, click mouse right button, insert sizing. Okay, choose the geometry with the help of control B body. Select this, enter body, apply. uh, Give the element size. You can take number of elements. I'm taking the element size 10. Then again go to the mesh, click mouse right button, generate mesh. This is the way to you can divide that entire structure into your required elements. The next step is static structures. First we need to apply the supports. Click mouse right button, insert fixed supports. The next one is I can choose static structures. Click mouse right button, add force. First choose the fixed supports. We know that with the help of this node option, we know that first node and this last node both are fixed. Click on apply. Next one, go to the force, geometry. We know that in between these two fixed nodes, this second node, third node, fourth node. For selecting these nodes, just you can hold control button, select second, third, fourth nodes, then click on apply. Here the defined by components. The vertical load is minus 90,000. That means the load is acting downwards. You can take the minus sign. Each node having 30 kilonewtons, so total load is 90,000 acting downside. If you have any doubt, you can change the orientation. Just click on X, then click on Z. You can see it, that load is acting downward direction. Okay, the last step is solution. Choose the solution, click mouse right button, insert deformation total. Again click choose total deformation, click mouse right button, insert probe force reaction. Then ch choose solution, click mouse right button, insert deformation directional. In the directional, select the all nodes 1 2 3 4 5 6 7 8. Apply and change the orientation. This is the y axis. Here the force reaction boundary condition fixed support. Now for seeing the results, choose the solution, click mouse right button, evaluate all results. See the total deformation. You can see total deformation. Units are in millimeters. 0 minimum, 6.0724 maximum. Force reaction. This is the directional deformation. You can also see the animations for total deformation. Just play here. Okay, next one is force reaction animation. Next one, directional deformation. You can see the animation. Okay, this is the way to you can solve any type of truss members in ANSYS Workbench software. Okay, I hope this solution is very clear to everyone. Thank you for watching. Please do like and subscribe my channel for more updates.